Okay, part B. So we're working with logarithmic functions. And again, I told you that exponential functions and logarithmic functions are inverses. And so basically what we're looking at is you can, depending on what kind of problem you're doing, you can write it as an exponent form or you can write it as a log form. Similar to when we did roots, and we could put it in a root form or radical form, or we could put it in exponential form. Okay, and as we learn more about this, you'll understand a little bit more why. But basically, you start out with some base to an exponent and you get an answer. All right, a base to some exponent gives you an answer. For example, right below, 3 to the 4th power gives you 81. Okay, but sometimes you're solving for other pieces. Log, notice where they put the base, so log base b of a is x. Okay, and notice this x here and this x here, they're the same. And you're going to hear me say this over and over and over again, even though I don't get to see you every day. The answer to a log problem is an exponent. Okay? So when no matter what I'm doing, if I'm writing it in log form, the thing that goes over here where I've underlined this x a bajillion times with my purple, that is where the exponent goes. Okay, and again, this would be log base b of a equals x. So if I'm rewriting this, where's my exponent? It's 4. So this is going to be log, what's my base? 3 of 81 equals 4. 3 to the 4th power is 81. 3 to the 4th power is 81, right? So my answer here, that's an exponent, okay? Again, what's my exponent? So log base 7 of 1 equals 0. Log, what's my base? 5 of 1/5. Again, what's my exponent? All these numbers over here are exponents. Okay, so again, what's my exponent? A half. So log base 9 of 3 equals 1/2. Log base a half of 8 equals -3. All these are exponents on the right side of those equations. Okay, so this is, we started with exponential form and we turned it into log form. In these examples, the next set, we're starting with log form and we're going to put it back into exponential form. So we're just translating it right now. But again, remember, again, I'm going to say it again. The answer to a log problem, problem is the exponent. So if I look at these 4 examples in this next section, 7 is my exponent, -1 is my exponent, 0 is my exponent, 1/3 is my exponent. And just because I can, I'm going to change colors. Okay, so putting it back to exponential form, what's my base? Remember, my base is always this little tiny number that's being written. So my base is 2 to the 7th power, that equals 128. 8 to the -1 power equals 1/8. 6 to the 0 power, just like anything else to the 0 power, is 1. 64 to the 1/3 power, in other words, the cube root of 64 is 4. Okay, and again, right now, all we're doing is translating back and forth. Why do we need to practice that a little bit? Because when we start manipulating these and we start solving equations with them and stuff, if you don't remember which things are in which places, it's going to be hard to work with. Okay, and then the last thing for this section before you guys get to do some practice is these, if you notice, don't have a base, or they don't have a written base. So what happens if there's no visible base? Well, we have all kinds of things. Just like if I say x, what does that really mean? 1x, or 1x to the first power. If I say x squared, this means 1x squared, right? So if there's no visible base written, the base is 10. So that's like having a little tiny 10 right there. But again, what is the answer to the answer to the log problem? The answer to the log problem is the exponent, right? So there's my exponent, there's my exponent. So if I want to translate these, even though there wasn't a number down there before, this really means 10 to the second power equals 100. That should make sense. 10 to the -3 power equals 1 over 1,000. Okay, so you guys are going to do some practice just translating back and forth on the worksheet that you have. You're not going to worry about the graphing one. We'll deal with that one tomorrow. But this is just translating between exponential form and log form. Okay, we'll get that part down and then we'll be able to go on and move on and do some more stuff with that. Okay.